opposite of that is still the same thing. Yeah. Unfortunately, you have to now you're learning the what we call the foundational skills and also maybe intermediate skills. IT doesn't stop evolving. It's both its benefit and disadvantage. Disadvantage because you never stop learning. But that's the benefits. That's the good thing about it, right? All right, huh? So for Farah, I think you need to have more practice, lah, right? Because you will find the same or similar situation in exam and definitely during SBA later. So of course the SBA is practical, not test, yeah. So this goes to also Noel and Calvin, right? You have to practice to prepare for the next test is the practical test, the SBA, skill-based assessment, and you have to do it within the allocated time, right? So figure out a way. Not only you need to practice so you get used to it, so it becomes second nature, at least on that day, yeah? But you also need to find a way that works for you guys, right? Find a way that works for you guys. Um, you have to adapt to online assessment. Online assessment means you have access to all the data, but it's no point if you, because too much data is also not good, because it's useless, because you can't summarize, you can't. So do you have any way that works for yourself, a way to consolidate, summarize, and have at your fingertips all the data, all the info, all the knowledge you know you need to um, retrieve, yeah? Right? Of course, some of it, most of it is inside your head already because you're doing revision, you're practicing, right? But you have to be strategic. You have to think about approaching any test, any exam strategically, right? Okay, I believe Farah and maybe Noel, Kelvin sometimes, not sure, but I know a lot of our IT students, they do play games, right? Uh, I play games since I don't know when, right? And now less time, but I wish I also have time to play games. If I have the time, I want to play games. It's very therapeutic, yeah, and also it's always a challenge, and it's always a way to relax as well. But how do you approach it when you are playing a game, right? Whether it's the multiplayer game, single player game, or maybe physical game, at at school, at campus, or with your friends. You approach it with a strategy. You want to do better, right? You have to strategize. You must have a strategy going in. So this is sometimes lecturers don't mention this because sometimes they think it's they're so used to it, so they don't mention it anymore, right? So I will give you, I will let you know, right? All the good students, they do strategize. They don't go into the exam without any strategy at all, right? But unfortunately, there are only few generic strategy that works for everyone, because each one is individual. Each student is individual. That means individually you need to find out what works for you. Some students, they like to have written notes, and that is make them very efficient. Some students, they prefer mind map. Some students, you know what I mean, huh? Right? So this skill is not only during study, yeah. This skill can be carried into your career, right? Your ability to summarize, to make sense, and also to have those information at your fingertips also carry on to whatever you're doing, right? Your career, maybe mostly career lah, because I don't think in day-to-day life you need to have all this, but some people do, right? Some people do. I look at productivity videos, especially with an app called Notion, and then this is this guy. Everything. Sometimes you want to live your life spontaneously, of course, but sometimes you need to have some way, because we are bombarded with information all the time, and sometimes those information we need. But how do you retrieve when we want to retrieve it? So this is also your you have to figure out, right? So in terms of not enough time, Farah, I can advise you this. You need some time to think about it, because you're not 100% sure or familiar with the topic. I can tell you, right? So you need some time, right? And that not only you, but every student, when they see a topic that they're not 100% sure, right? They need some time to figure out what the question is asking, what the question all about. So that takes precious time already, yeah. Then once they figure out, okay, they need to extract back the information, how to answer it, right? So um, if you have not memorized, then you have to look for it. So not memorizing simply means then you have to figure out what is it, and that takes crucial times again. So the how to solve it, like just like any other problems in computing, yeah, you can solve it. Not familiarity, right? The best way is get familiar with it, with the topic. When you scan questions and you're not sure about it, then you need to make sure you don't have that feeling. That means you need to familiarize with it. Find articles. Find sometimes you don't if the topic is too dry, or too few details, right? Then you can find other sources. Find other sources. Uh, that's why I asked you to guys to have a look at the net acad, because the way they show or deliver, they include animation or videos that goes direct to the point. Yes, in YouTube there's a lot of other videos, but sometimes, because depending on their pedagogy, like what they want to deliver, sometimes they go until they then finally they reach the what you wanted to know. Okay, so it's, take some time to filter through all the information out there, right? The second problem, right, Farah, is retrieval of the information. Once you identify, how do you retrieve that information? If you can't memorize it, because basically uh, difficult to memorize lah, right? But unfortunately, and the only way to memorize is to actually keep working on the problem, keep revising the work. But you got opportunity that this is open exam, open test, open book, which means all you need to do is codify the information for easy retrieval by yourself. You have a system to retrieve. Once you are, oh, this is what, and you know, is asking this because they're not. The question is not going to ask you guys about something that is not covered, so it should be covered. Easy retrieval. Okay, it's like your own personal knowledge base. How do you retrieve those information? What we want to do is to provide shortcut for yourself to go from looking at the question, understanding the question, and retrieving the information. Now, once you see the information, it should trigger something in you because you have already revised, right? So some students fall into the trap where once they see the information, they start to copy or they start to direct, translate, or rephrase. That's not supposed to be how it works, right? It's supposed to be you retrieve the information, then that seeing the information in front of you trigger yourself to, know what to do, what to write, right? So if you find yourself in this situation, figure out your own algorithm, your own way, right? And I can tell you, it's not nothing to do about only computer networks. It has everything to do with your system, where you approach your strategy, because the same thing will happen to another topic and another topic and another topic. So why not create a system, and along the way, right, fine tune the system for yourself. After a few iteration, you'll get a very, very good system that works for yourself, right? Because I can tell you, no one goes into this kind of thing without any systematic way. That means they didn't prepare it, no strategy. Always there is a strategy, right? Just like when nobody go into a games competition without strategy. Always have a strategy, right? Why don't we apply that concept into our learning, into our assessment, right? So there will be a strategy also in learning, in the sense that whatever, uh, let's say I tell you guys, what is the best way for you to retain that info? Again, uh, our brain capacity, although some people say it's unlimited, actually in practical way, it is limited. We have short-term and long-term memory. So probably if you can still remember what I mentioned yesterday is short-term, but to transfer between short-term to long-term is the difficult part. You need to keep repeating so for it to work very well. To be an expert in something, right? Um, if you have you heard about it? 6 years, 6 to 7 years to be an expert, to be considered expert level in something. So 7 weeks not going to be enough, right? So you must have a strategy, a system of for yourself. How you going to not retrain, retain that info? How you going to keep the notes so that is for you, right? It helps you to see. Sometimes students like to put their notes, okay, because that's how they can organize their thoughts, the information. Sometimes they create mind map, right? Sometimes they like to physically or manually create the mind maps. Sometimes they like to use digital tools, right? So there is a software called Notion, Notion, that is available for free for individual, where and you can see a lot of people actually use that. Okay, sort of like free form. I would say it's database, but it's not really, because the interface is very, very nice, very simple. But you can use it as different ways on how to, you know, and you can see other people how they do it lah. I'm just giving uh, some hint lah, something, right? If you discovered that something doesn't work, it's time to change to something that probably work better, right? Don't keep repeating a system where you know. So when I talk about system, you guys are software engineers or learning to be a software engineer. So you guys are supposed to be able to critically look at the system, see what is the um, what inefficiencies you see in the system, so you can re-engineer or you can design another system to, you know, to be a better system compared to the previous one. And it just so happened that the new system will be implemented or applied digitally. That's why you write software, correct? So practice, be critical about your own system, yeah, hack your own system, create your own system, right? It's fun to figure out which one or what kind of system works for you. In any case, you're studying, right? Although we have all this technical knowledge that you need to know, but at the end of it, you apply it to create a system, to look at the current or previous system, see what's lacking in it, and design another system to replace or to complement. Software engineers do this, right? Nah? They figure out how to solve a solution using software. Okay, and the software, if you think about it, out of your own design, out of your mind, out of your own mind. That's why sometimes computer science is also called School of Arts and Computer Science. The arts part comes because of the the level of designer and creativity that you have to come out with, right? But you are using very solid methodology, principle to guide your design. That's why there's the software system development always um, you're taught about how to formally find out the user requirement, how to design this database, how to design. You use tools, modeling tools to help you, right? To help you to formalize your thinking, right? Without the tools, your thinking is in your mind, or you put it down, you formalize it so you can uh, view it, okay? The logic of your design, right? And then you implement is the right the code. Of course, you have the pseudocode, you have the flowchart pseudocode, the algorithm that you implement using a language that you deem suitable for that system. And at the end, right? I think you know already what is the software development cycle, right? Okay, so I will try to mark your test this week, all right? And give you maybe feedback next week, right? But you guys should start to think about when you're doing this packet tracer. I hope you're doing also the homework one, huh? Right? Think about the end point of this is that you will be able to do the SBA assessment, the assessment, skill-based assessment, that one, which means you already seen the topics. The topics of the practical basically mirror what you learn in the lecture. It's just the application of the knowledge you learn in the lecture, right? Actually, computer networks are very practical, very practical. A lot of those, yes, there are some theories, but they are usable, they are practical. That means it's used in the real world. So, for example, yesterday we learned about Eigrp. So today, right, we apply those commands that we learned, but we already know what is Eigrp and what is purpose, right? What's the characteristics of that protocol? What's purpose? Why we use it, right? And then we then practice it today, means you apply it. So you can see in your Google Classroom, okay, that 5.16224 packet tracer configuring basic Eigrp with IP version 4, right? So you learn how to configure the Eigrp, and this one works with IP version 4. Now for the two, the other two is just a self-assessment uh, review. Okay. Um, Last week I think you have one, so you use this as, how to say, as revision. I would imagine that this is like revision because you've already learned. So this week you got this one to review, to keep your knowledge fresh, right? Because by the time week 7 you want to do the SBA, probably if you don't keep reviewing, remember, 6 to 7 years to become expert. We're not asking you to be expert. We just want you to remember back. Short-term memory, long-term memory. Short-term memory means after several days, whatever you learn, it might be lost. Maybe next week, lost already. So you have to refresh again, right? Just like our that you guys already studied COA, right? I think with Sue, right? COA, Computer Organization and Architect.
Yes.
Yeah. So just remind me of the one of our current chip RAM. Every microsecond have to refresh during refreshing, and that's why it's slow. That's why our RAM is slow because of the technology. Every I think microseconds, I forgot what's the value, but it needs to refresh because of electrical leakage. Basically, the place, the capacitor where it stores the voltage just leaking electricity, right? So have to be refreshed. And during refresh, um, no operation can happen on that RAM. Means cannot read, cannot write during that that period to refresh the electricity inside your RAM. So so basically, our brain is like that. But for short-term memory, you just learn this week, next week, definitely, maybe depending on individual, but how many percent have you lost, right? So in order to encourage transfer from short-term to long-term, right, you need to impose on your own brain that the importance of that knowledge, meaning you revise, right? You revise. When your brain see it again, your brain, oh, this is important. So the neurons in our brain, okay, the signal flow through it again. So it's, that's what we implement also in neural network, because we've read what the brain neuroscientists mentioned about retention of knowledge, of memory, right? It's our neuron forming connections, weights, right? So if you keep repeating something, your brain think that is important and will dedicate those neurons to in terms, because our brain works with electrochemical, you know, what, right? So we have an analogy, but our digital form with the neural network actually is just a copy, not a very good copy of our own neurons in our brain, but there's a mechanism, right, that your brain neurons will over time, if you keep repeating something. That's why when people want to be good at something, sometimes when they play badminton, tennis, whatever, they keep repeating the same movement so that it's hardwired into the brain, right? So that's why very careful also. If you don't want to something to become a habit, don't keep repeating it, because your brain will be fooled to think that that thing that you keep repeating is something that is important, so it will remember and it form a habit. That's why it's very difficult to remove the habit, because it's encoded into our neuron already, right? So that's, I'm just telling you the background why we 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 say please revise. It's just simply the reality of how our brain works. If you don't revise, your brain thinks that that information you recently acquired is not important enough, right? So the neurons will not get uh, hardwired to retain that information. That's simply that's the basis of our our brain. So you have to revise. So when your brain see that you keep on uh, accessing this information, then retention of the memory means it will be hard coded into your brain, right? So that's why you have to, like I said, you have to have a system. You understand your own self. What is the best way for you to revise or to retain or to, sometimes there's so many things, right? and it's very difficult to retain everything in our mind, right? So we have technology. Why don't offload some of the information, but keep a way to access it, right? A way to catalog it, access it, so it's easy for you, right? So let me come back to our this one, configuring basic Eigrp. Right? Have you guys downloaded it?
No.
Not
Yeah,
yet.
the 5.1.
Yeah.
Yeah, I downloaded.
Okay. So let's have a look at that. The rest, please do so if you have not. The packet tracer configuring basic Eigrp with IP version 4. All right. So previous week we have I think 4.1 implementing inter-channel, the first assessment, and then the in-soft assessment is review lah, right? And then packet tracer, HSRP, the duplication of um, router gateway, okay? Right. So let's just have a look here. Okay. Just show my screen here. Okay. All right. So you guys look at the screen. And I think you also, well, you can look at this, you can open it later. All right. So we have three routers, topology wise, R1, R2, R3. And we already learned, during our lecture, Eigrp basically is a way to populate a router's routing table with information that is about remote networks to it, right? So for example, if we are considering R1, means, can you guys see my pointer?
Yes.
Can.
Okay, so this upper part, LAN up here, that's connected to R2, right? That is a remote network to R1 because it's one hop away. So R1 don't have any idea about that network. Similarly, with the other network, right? The 192.168.1.0/24, that is one hop away via R3, the router 3. That also is a remote network to R1. So you can take the perspective of R1, R2, R3. You can find the list of individual to each of the router. You can find a list of directly connected network to that particular router, and also the remote network. So since each of the router know about the network around them, the directly connected network, that router can share that info to another router where the other router cannot see that directly connected network to that network. So let's say I give example R1. R1 know this. So R2 know this, and this networks, but it does not know this one and this one, right? So R1 knows this info, so share it with R2. Now R2 trust R1, so R2 insert the entries, the two entries inside this routing table, right? And it's part of the entry is to say that in order to get to those remote networks, have to go through which interface, okay, of the next hop. So in order to go to this 172.16.1.0/24, basically R2 have to go through the interface on R1, right? Correct, yeah? All right. So all the information is basically for addressing purpose is given in the table beside it, right? So the protocol to allow these routers to speak to each other, to share those information, right? We saw yesterday, yeah, is EIGRP, extended IGRP, and or enhanced, sorry, enhanced GRP, right? And we've seen all the commands yesterday, the hello, okay, which is unacknowledged, but the others, the update, query, and reply are all acknowledged. That means if R1 send um, hello usually is to discover your neighboring router. So it's possible they're not going to reply. So you don't expect acknowledgement. But the other like update, right? You when you send, let's say from R1 send to R2, R1 will expect R2 to acknowledge. All right. So this is the context of this topology, right? So we identify for us when we look at this topology, we straight away identify in the context of EIGRP, we identify for each router what are the directly connected networks and remote networks for each of the router. Okay, so that we have an idea. Okay, so what is going to be shared between them. Right, so here is the practicality of it, where we learn how to configure to use EIGRP in our Cisco router. After we perform the configuration, we're going to verify. That means check whether our configuration was correct, right? So finding out whether all the configuration we did was correct lah. So we learn a few commands to access those information that we can then verify. All right. Um, Configuring ARGRP here, step one, enable. So we know that one is actually the AS, right? Autonomous systems, right? And we know that we can use it. We can put in our own. But if we want it to be on the internet, right, and accessible on the internet, and our network is large enough, right, because we are ISP or we are telecommunication, then that value there is to be assigned by one of the governing body for internet lah, INA, right? Okay, but for our purpose, no problem. We just put in a value to indicate that all the routers within the same AS, okay, they are going to communicate to each other, right? So they won't communicate with, okay, those two areas, those two AS, different AS will still be able to talk to each other using a different protocol, the BGP, but that one's for later, okay? Right, for here, how do we know that, how we configure R1, R2, R3 to talk to each other is to first place them together in the same AS. So this command, router EIGRP1. Then when we have routers, we need a way for the routers to identify each other, right? Okay, so this is where this, no, I think that one is router